Alright, so now that we have run all the required setup on the scope, let's start making the measurement, right? So the first thing we'll do is connect the USB cable. I have my dual input USB on this. The only reason I'm using dual is the inrush current on this board is a little higher than what this USBs can support, right? So if you're using this board, make sure you use the dual input, right? For your dot, it shouldn't matter, right? So there it is. We'll connect this in and the board is on, right? What I'll do is I'll turn the switch on, so it starts with the gate measurement, and I'll turn the high side, the MMCX side on, right? So now all the measurements are running. It's obviously clipping because it's set up for auto, right? I'll start with the auto set, so it at least gives me a frame to work with, and it should start giving me results that kind of make sense. All right, there we go, beautiful. So what the scope did was it basically stacked all these measurements on top of each other, right? So that's a great way of doing it. Now, one of the tricks that you should be using, especially for measurements like this, is try and center that measurement offset using the scope menu, right, or the probe menu, because it really helps put a signal in middle of A to D, and which gives you the best results, right? So I'll show you how to do this, right? So click on this guy right here on the channel 1, right, and you know what the offset is. It shows you what the offset is, right? So this is a VGS measurement, and the offset is set for 2.3 volts, which is perfect, right? We'll look at this one right here, right, and 25 volts, right? So that's perfect, because that what it does is it basically takes the signal and sets it exactly in middle of your A to D, right? So that gives you the best results, right? You'll do the same thing for the passive probes, and you can see the signal right there is good. And for the VDS signal, we have 25 volts because the VDS signal is 50 on this board. Okay, there you have it. Now, if you want to align them, which I personally like, I'll just go and align the signals at some center point, so that gives me much easier way to view them. We'll do the same thing for all the signals, so I can see how they stack up with each other. And then there's a fourth one. All right, there we have it, right? And now we'll change the scaling and look at actual measurements, right? So for this first measurement or test, what I want to do is I just want to turn off the VDS for now, right? So let's turn off channel 3 and channel 4, right? So I'll just turn this off right here. I'll turn off the channel 3. For now, right? So all you have is VGS measurements on the low side and VGS measurement on the high side, and just see what it actually looks like, right? So let's change the scale, right? And I'm triggered on the first channel, which is the low side VGS measurement, right? So usually the low side measurement is not as difficult, right? So what I'll do is I'll change the trigger and keep it on the channel 2, which is the high side, right? And this is where the fun begins, right? So right here, I'm gonna align it right there, and then we are going to change the trigger and take a look at that. I don't know if you can see this. Let's increase the scale on this so you can actually see the signal. I'll increase the scale on channel 2 as well, so we can actually fit the signal in. Oops, too big. All right, there we go. So now you can really start seeing the gate signal and see how beautiful that looks, right? So before I started using this probe, I could never see Miller plateau on a gate measurement, right? And you can actually see with that, right? So right there, you can actually see a Miller plateau, and then it charges again and goes on. This ringing is because of the layout issues and stuff we have with this board, but you can really see all the details in that charge cycle, right? Now, remember we are talking about bandwidth and how that affects everything. So let me show you something. What we'll do is we'll turn on the cursors right here, right? And we'll bring that cursor in to our gate measurement, right? So let's bring it right here and bring this guy right here, right? So I'm going to change the scale on this so we can actually see this. Okay, right, so there we go. All right, so now take a look at this. Take a look at the delta right here. It says 1.6 nanoseconds, right? So if you had to actually see the Miller plateau and all this ringing that's happening on the Miller plateau and the way it's charging up, turning on the FET, you really need to see 1.6 nanoseconds, right? And that's where the bandwidth comes in, right? So we have been talking about bandwidth a little bit and why you need the bandwidth at the CMRR, right? So this is a differential floating measurement. It's not even a ground reference measurement, and you can actually see how the gate turns on, stays on Miller plateau and turns on again, right? So that is the beauty of this isolated system. All right, so that being said, this is your gate measurement, and obviously you can put cursors on your turn ons and turn offs, look at the dead time and all that stuff, right? What I really want to show you is the comparison of gate with the VDS measurement, and this is where we'll turn on the channel 3 and channel 4, right? So now this is really cool, right? So take a look at this and let's see if we can see the dead time, right? So right there, right? So your gate comes on and the red signal is the VDS signal on the high side, right? So I'll get the red signal right here. Let's do this. Let's turn off channel 1 so we can see the signal very clearly. Oops. Okay, there we go. So red signal is the VDS signal on the high side, okay, right there, okay, and the green signal is the VDS signal on the low side, right? And now you can really see the transition that's happening between VDS on the high side and the VDS on the low side, and you know exactly when the FET turns on, it goes through that, you see that blip right there, right? That's your dead time, right? So you can actually calculate your dead time right here where the signal actually turns on, and there you have it, right? So you can really optimize where your dead time is. No phantom ringing, no phantom problems, right? So that's how you can really look at the performance of your gate drive and at the same time optimize your dead time in a really crisp, clear way, right? Perfect. So we'll go to the next section and we'll talk more about, you know, how this compares with other methods of doing this measurement.
Find out more at Vicom's website.